All right, let's talk about getting data. That's ultimately what it's all about. We're going to look at how we'll implement a repository via a controller to expose the methods necessary for people to access data from your Couchbase database. So first off, why would you expose data via a repository? Well, it's probably quite straightforward for anybody watching this. It's because your data may need to be accessible by more than one system. In this case, we may be showing how to develop a REST API, but you would want to have a central access point for the underlying data. So we're going to do that by implementing a repository pattern here. Now, we'll also be using generics to ensure type flexibility because particularly with a flexibly schemed database like Couchbase, the types that you support will evolve over time. Now, as you've already seen, we're going to base all of our data handling around a core entity-based class that exposes common fields like created, update, type, ID, and so on. And then that is typed, and we pass types through our repository as needed. Now, the core action with Couchbase from a code standpoint is through your bucket. We've already looked at Cluster Helper, and here you see it has a getBucket method that allows you to get a reference to one of the buckets that you've configured, as you saw earlier in the course. And that's going to be held locally here in our repository, typed as an iBucket. Now, of course, you could have some dependency injection framework in place here, likely you would, but I guess on the one hand, working with a database is science, whereas dependency injection is kind of like religion, and we're just not going to get into that here in this particular course. I'm sure you understand. So how do you interact with the bucket? Well, that's going to be a lot of the action going forward through the rest of the course. iBucket itself is in the Couchbase.core package if you're out looking in the documentation, as I expect you will be at some point. But this is how the core functionality of the Couchbase API is exposed. And so it has categories of behavior like you'd expect. You can get individual documents or get documents based on a list that you pass to the get method. There are insert, replace, upsert, and remove methods we're going to be looking at through the rest of this short course. A query method to support nickel queries, increment and decrement operators for working with cluster-wide counters, we'll also be looking at that. And then if you're working with physically adjusting the documents that are stored in the database, there are append and prepend operations as well. We don't go into those in this particular course, but they're supported and documented. So when you get a document, the result is going to be wrapped in this iOperation result type, unless of course you get a list of documents back via get, in which case it'll be a dictionary of those results. Now, another thing to bear in mind is that all of these bucket operations come in both synchronous or asynchronous versions. Now, in this short course, we're going to be introducing the behavior via the synchronous version of these methods. But bear in mind, you can have an asynchronous framework for all of this and work with it all via callbacks. So, in interacting with the bucket, as we said, when you get a value back, you're going to get this iOperation result. Note that it's generically typed. So again, that wraps each resulting object, and it exposes a set of properties such as CAS, which is a check and set value that can be used for one approach to optimistic locking. There's also a durability setting, which relates to the newer durability level approach to ensuring durability of documents. There is an exception if one is thrown, something extending system.exception out of .NET. That's also available through this result object. The document key itself is in the ID property. If there's an error message, it's in message. There's a Boolean flag as to whether or not the result was successful or not, and then the value itself. The value is going to contain the locally mapped model corresponding to the JSON result that was received based on the type that is being passed around. So to expose this repository via REST, well, we'll implement a controller. Now here we're getting into behavior that goes beyond the scope of Couchbase. This is Microsoft's API controller from the Web API 2 framework for ASP.NET. Here, we're exposing the functionality of our repository within the controller by getting a local reference. Again, we're not demonstrating dependency injection here, although you might well implement it in your own approach, in your own application for this. The API controller itself is going to map the HTTP verb and the incoming route to corresponding methods. For example, here by default, an incoming get with no parameters is going to call the get method. Later on, we'll see that that might invoke a get all. Now, how you configure these routes all happens, as we saw briefly earlier in the course, in the Web API config file over in app start. We'll take another brief look at this here, as well as point to documentation from Microsoft on how to customize. Now, of course, parameters could be passed here, and if there's a parameter to the method, then the route is going to anticipate a parameter would be passed, and that's how the mapping gets created here to invoke the correct method of the controller. If you get a collection back, collections will be returned as a generically typed IEnumerable, and then individual documents would be returned by their own model type. Again, API controllers doing the underlying magic of mapping JSON documents to the model that's been created. We'll talk a little bit later on in the course about path and verb customization. It'll be demonstrated in a later lab. We'll see the documentation in just a moment. So in the lab, you're going to go about creating the controller in the repository to get the documents. Let's take a quick look at a few things here. So first off, in the Web API config file, which would be in the app start folder, this is created by the project itself, and this is the default route. API / and then the controller identity followed by an ID value. That is the default expected route. And so in customer controller, we could have a get method that receives a particular parameter like string ID, and if an incoming route has a get verb with API / literally customer / some value, that will map over to this method. Now in turn, this is calling a method on the underlying repository. The repository, we're just creating an instance and dropping it into our controller here. Again, this is where you might be implementing a dependency injection framework. The repository itself will expose methods, and this is where a lot of the work for the remainder of this course is going to be, is in this repository file, but this is where we would invoke the underlying get method from the bucket. We got that bucket through the cluster helper, creating our local reference. We'll invoke appropriate methods and pass them back, and then in turn the controller will call these methods. And we have a interface in between to help keep things clean and relatively best practice. Now, the routing that happens in Web API config is well documented by Microsoft, and you might want to go out and take a look at this. If you're new to it, just Google attribute routing in ASP.NET for Web API 2. Easily found. Now, of course, once you get data out of a database, you're probably going to want to at some point turn around and put data back in. That's what we're talking about next. So again, we encourage you to take the time for a bit of hands-on practice to get the code into your fingertips and into your brain. When you're done with that, come on back. Should only take you 15 minutes or so, and we'll take a look at inserting data to the database. We'll see you soon.